So let's find the limit of f of x times h of x as x approaches 0. All right, we have graphical depictions of the graphs y equals f of x and y equals h of x. And we know from our limit properties that this is going to be the same thing as the limit as x approaches 0 of f of x times the limit as x approaches 0 of h of x. And let's think about what each of these are. So let's first think about f of x right over here. So an f of x as x approaches 0. Notice the function itself isn't defined there, but we see when we approach from the left, we are approaching, the function seems to be approaching the value of -1 right over here. And as we approach from the right, the function seems to be approaching the value of -1. So the limit here, this limit here is -1. As we approach from the left, we're approaching -1. As we approach from the right, the value of the function seems to be approaching -1. Now what about h of x? Well, h of x we have down here. As x approaches 0, the function is defined at x equals 0. It looks like it is equal to 1. And the limit is also equal to 1. We can see that as we approach it from the left, we are approaching 1. As we approach from the right, we are approaching 1. As we approach x equals 0 from the left, the function approaches 1. As we approach x equals 0 from the right, the function itself is approaching 1. And it makes sense that the function is defined there and is defined at x equals 0, and the limit as x approaches 0 is equal to the value of the function at that point, because this is a continuous function. So this is 1, and so -1 times 1 is going to be equal to -1. So that is equal to -1. Let's do one more. All right, so these are both, looks like continuous functions. So we have the limit as x approaches 0 of h of x over g of x. So once again, using our limit properties, this is going to be the same thing as the limit of h of x as x approaches 0 over the limit of g of x as x approaches 0. Now what's the limit of h of x as x approaches 0? This is, let's see, as we approach 0 from the left, as we approach x equals 0 from the left, our function seems to be approaching 4. And as we approach x equals 0 from the right, our function seems to be approaching 4. And that's also what the value of the function is at x equals 0. That makes sense because this is a continuous function. So the limit as we approach x equals 0 should be the same as the value of the function at x equals 0. So this is going to be 4. And let's think about the limit of g of x as x approaches 0. So from the left, it looks like as x approaches 0, the value of the function is approaching 0. And as x approaches 0 from the right, the value of the function is also approaching 0, which also happens to be g of 0. G of 0 is also 0. And that makes sense that the limit and the actual value of the function at that point is the same because it's continuous. So this also is 0. But now we're in a strange situation. We have to take 4 and divide it by 0. So this limit will not exist because we can't take 4 and divide it by 0. So even though the limit of h of x as x approaches 0 exists, and the limit of g of x as x approaches 0 exists, we can't divide 4 by 0, so this whole entire limit does not exist. Does not exist. And actually, if you were to plot h of x over g of x, if you were to plot that graph, you would see it even clearer that that limit does not exist. You would actually be able to see it graphically.